One of the first methods of solving systems of equations is to graph your two equations and take a look where the 2 points intersect. With modern graphing software, it's fairly easy to find the points of intersection. And so this system of equations, x minus 1 plus 1 is equal to 0, and x squared minus 6x plus y plus 3 is equal to 0, we're going to graph using technology. Before you go about using the technology, though, it's always good to just do a mental check and see what kind of graphs you have. Notice this first one, all of the exponents are 1, so this is a linear function, and the second equation has an exponent of 2, so it's quadratic, and its graph is going to be a parabola. Alright, I'm going to use GeoGebra and Wolfram Alpha to show you the graphs of these two functions. Alright, here we go. We're going to launch GeoGebra. There we go. Let's make the window full screen, and we're going to center the axes and turn the grid on. Alright, now let's enter in our two equations. Here's the first equation. You'll see we get a straight line, and next we're going to enter the parabola. Let's see, we get a parabola with its vertex in quadrant 1, and you can see that the line crosses the parabola in two spots. Alright, the first spot being at 1 and 2, and the second spot being at 4 and 5. Alright, now let's take a look at how we do this in Wolfram Alpha. In Wolfram Alpha, you can type both equations into the search bar, separated by a comma. So there we have x minus y plus 1 is equal to 0, and next x squared minus 6x plus y plus 3 is equal to 0. Press enter, and it sends it off over the internet, and you can see again we've got our two lines, or our line and the parabola, and our 2 points of intersection. And Wolfram Alpha nicely gives us the coordinates of those points: x equals 1, y equals 2, and x equals 4 with y equals 5. Alright, so we saw from Wolfram Alpha and GeoGebra that we have two graphs. One's a parabola, and the other is an oblique line, and the two graphs crossed at the points 1 and 2, and the second point is at 4 and 5. Now, we should just make a quick check and see that these two graphs are, or these 2 points are in fact the solutions of our system. And to do that, all you have to do is substitute the point into each equation with x and y and verify that you get the same thing. Alright, so let's take a look at the point 1 and 2. In our first equation, we'll make sure that our linear equation is first. Let's see, the left-hand side of this equation will be 1 subtract 2 plus 1, which is equal to 0. And the right-hand side is 0. These two values check. So we're good in equation 1. In our second equation, we get 1 squared minus 6 times 1 plus 2 plus 3 in the left-hand side. Oh, I'm sorry, I forgot to write that. In the left-hand side of the second equation, we get 1 squared minus 6 times 1 plus 2 plus 3, which is 1 minus 6 plus 2 plus 3, which is equal to 0. And since the right-hand side is equal to 0, we see that the point 1 and 2 is in fact one of our solutions. Alright, next we're going to check that the point 4 and 5 is one of our solutions. So again, in equation 1, we have the left-hand side being 4 minus 5 plus 1, which is equal to 0, and the right-hand side of equation 1 is 0, so it checks out there. In the second equation, the left-hand side is equal to 4 squared minus 6 times 4 plus 5 plus 3, which is 16 minus 24 plus 8, which is equal to 0. And that's the same as the right-hand side. So both of our points, 1 and 2 and 4 and 5, are point solutions to this system of equations. Alright, moving on to example 3. It says solve the system graphically and verify the solution. And we have for our system 2x squared plus 16x plus y equals negative 26. Right away, as I recognize that that's a parabola. And for my second equation, we've got x squared plus 8x minus y equals negative 19. Noting the square term, I see again that this is a parabola. Alright, how many possible solutions do you think are possible? Well, when you have two parabolas, since we don't know what they look like right now, maybe one looks like that and one looks like that. They could be two parabolas that don't cross, so there could be 0 solutions. They could be two parabolas that just cross each other in one spot, and you could have one solution. Or, as I said earlier, they could be parabolas that cross in 2 points and have 2 solutions. We don't know off the start. Alright, and again, we're going to use GeoGebra and Wolfram Alpha to graph these and see where the 2 points cross. Alright, so let's launch GeoGebra again. There we go. We'll make it full screen again and center our axes. Alright, there we are, and we'll turn on the grid. Alright, now in the input bar I'm going to enter my first parabola, and it'll be coming up here shortly. Right, there it is, 2x squared plus 16x plus y equals negative 26. And now we'll put in the second parabola, and you'll see it come up here in a second with an equation of x squared plus 8x minus y equals negative 19. And you can see those parabolas cross in 2 spots, negative 5 and 4, and negative 3 and 4. Alright, so let's take a look at Wolfram Alpha. Again, we can just type both of our equations right into the search bar. So we've got 2x squared plus 16x plus y minus or equals negative 19, negative 26, and we also have x squared plus 6 plus 8x minus y equals negative 19. Sending them out through the interweb, we see again that we have 2 parabolas crossing in 2 points, and Wolfram Alpha gives us the coordinates of intersection as x equals negative 5 and y equals 4, and x equals negative 3 and y equals 4. There they are at the bottom. All right, having graphed these two parabolas, we see that one looks something like that, and the other looks something like that. Right? The first point of intersection is -5 and 4, and the second point of intersection is at -3 and 4. Right, now we're going to take a look and see if we get the correct solution. All right, starting out with the point -5 and 4. In equation 1, the left-hand side of that equation is 2 times -5 squared plus 16 times -5 plus 4. And so we get 2 times -5 squared is 50. 16 times -5 is -80, and positive 4. So that's -30 plus 4, which is -26, which is the same as the right-hand side. So our point works in our first point works in our first equation. Taking a look into our second equation for the left-hand side, we have -5 squared plus 8 times -5 minus 4. So you have 25 minus 40 minus 4. And so that gives us a value of -19, I believe. Yes, 21 minus 40 is -19. Hey, and that's the right-hand side. Great, so our first point works in both equations. Our second point, -3 and 4, we need to check that it works in both equations now. So into the first equation, the left-hand side of the first equation gives us 2 times -3 squared plus 16 times -3 plus 4. 2 times -3 squared is 18 minus 48 plus 4. And so we get 22 minus 48, which is -26, which is equal to the right-hand side. So that side is, that first equation it works well in. Our second equation, we take a look at the left-hand side, and we get -3 squared plus 8 times -3 minus 4, which gives you 9, minus 24 minus 4, which gives you -19, which is also the right-hand side. Alright, so when solving a system of equations graphically, use technology to come up with your points of intersection, and then you should do a check to make sure that your points are correct.